Hey everyone, it's Mr. Pletch here. This is the assignment 2 for evolution, the tutorial. So this one will be a bit quicker. There's 3 parts. I'm not going to show you where to find it. I think everyone, you've already done some assignments, you know where to find everything. Let me know if you need help with that. But part 1 is all about the peppered moth. Now, you've read about this. If you've done the learning module, you've already kind of played with this simulation in a more free-form way. Now there's going to ask you a lot of questions, and you should know it pretty well. It was a very important study because it really did show natural selection in action. It showed how the environment can be changed, and the selective pressure is therefore shifted in its directional selection to select for a different coloration of moths. And that changed the whole allelic frequency in England during the Industrial Revolution. That part is definitely the easiest and most straightforward, so that one will be the quickest. Part 2 is something called population change. I'm going to show you their example. I'm going to show you my example, which I find more fun. And then I'm going to let you know, if you need help with that, where to find the rest, so I don't give it all away. And part 3 is speciation. And this one is the one that is the most open-ended, probably requires the most thinking, and the hardest to just Google and find the answer. But that's a good thing. So I'll walk you through that and spend the most time with that. So let's jump into it. Peppered moth, part 1. Basically, you follow the instructions, and if you click this link, you're going to bring up this flash enabled thing. So I've never had a problem bringing it up. I use Firefox. Check that. I've never had problems with Chrome either. But you do need flash enabled. So it's broken down into multiple sections, and the keys here are life cycle of the peppered moth. So where would I find these answers? Well, if you hover over these, they're the sections. So, okay, life cycle of the peppered moth, and you're going to get some reading. And so you're just looking to find that answer. So how did the peppered moth avoid predators? So if I read that, I don't really see anything. So I'm going to continue on. And then we start looking at, okay, what are the predators? And how do they avoid them? Well, they do avoid predators by flying at night. So they're nocturnal. So they're active at night, and they're resting during the day. And since they're resting, they're not moving. Therefore, it's harder to see. So just for a simple way, active at night when predators are not sleeping or resting during the day. And if you want to go into the fact that they sit on lichen, you can here, but this answers more than enough because it's just a 1-mark question. And we see question 2 is all about what is lichen and how is it important. So you can answer the camouflage bit in that one. Now, please note that there are 2 things that's being asked of you here. So the one thing I've noticed in the first couple assignments is people will do the first half and neglect the second half. So be sure to fully answer questions. So some people might just say a lichen is, and that's it. But we need to know both sides of that to get the full mark, okay? So what is the lichen and how it's important? And if I keep clicking through, it says exactly what's going on. Covered in the small fungi called lichen, and they're important because the pattern, they camouflage in with them. So you'll find everything for that section under the life cycle. It's the same. The next one is called the impact of pollution. So these questions are all in this little section. So you can get it directly there. It should be really straightforward. Nothing from me there. Next section, Kettlewell's experiments. Well, once again, the next box. Shouldn't need much more help than that. What I will show you is the bird's eye view. So the last part is when you actually get to kind of play the game. So you get to be the role, and it is super important you do it twice. And it's super important you do it in both the dark forest, which is after the Industrial Revolution when the trees became covered in soot and dark, and also the forest before that. It says behave as a bird. So try choosing the moths that are most obvious first. Well, that's probably pretty straightforward. We're going to be seeing that too. I'm just going to quickly run through that one because I like playing it, and I'm a wonderful bird. So to get started, you just click through blah, 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 blah. And I'm going to go into the light forest first. And so you have all these things on the bark, and you're running around clicking. You can hear the bird smacking its lips. But yeah, I'm trying to eat. And as you see, obviously the darker ones in this regular forest, so before the Industrial Revolution, are much easier. I'm going to keep doing this, and I'm going to pause it now and skip ahead until the end. So I didn't make you sit through and suffer for the whole minute here. So at the end of 1 minute, we see how my ratios have changed. It started 50-50. By the end, I only had 85% light moths and 15 dark moths. So we saw that pressures of predation obviously made it much easier to see the dark moths. So in the assignment, very easy in my example, and they are different for everyone, I would just write that. Try it again with the dark forest, and that's it. Then you got to connect this to natural selection. So it's 2 marks. Here I would like to see you say, natural selection is this, and this is what it looks like with the peppered moths. So I'm going to leave that and question 10 up to you. Now, the next part, let's close the peppered moths. Let's bring this front and center. Part 2. Now, the idea of this one is you're going to be working with the mechanisms of natural selection, basically. Things that are going to impact it and the agents of change. So if you need this, review note set 11. All the information for you to be successful is in number 11. But let's look at an example of what this whole part is asking you, because it is out of 10. Basically, they're giving you a starting population. So here I have my starting population of butterflies. And then it's going to say, after this population is established, there's an agent of evolution, natural selection. So in order for you to get the full marks, I want you to just say, what is natural selection? What does natural selection look like in this population? And how will that affect your population? So what will that change? So here it says the starting population has less random variation in size. Now, so what that looks like is you're going to have the predators eating the larger ones because they're easier to catch. So the smaller butterflies are more difficult. So natural selection is going to favor the small ones. They're going to avoid predators more often. Therefore, small ones are more fit, and then the resulting population would have more small butterflies. It might not be completely small butterflies, but it's going to have more. Now, the next thing is, it says mutation. Now, you get to kind of decide a mutation, and I think you can have a lot of fun with this. Here they say, what the random mutation, it says the butterflies are going to have darker, lower wingtips. And so we're going to see, as a result of that mutation and what's going to happen to the population, a lot of them are going to be darker. Now you have to go through 5 of these, and your starting point are these brontosaurus type things, these long-necked dinosaurs. Now I'm going to walk through a little bit of my own example. I find it's better, and I can show you kind of exactly what I'm looking for to get that full mark, or the full 2 marks for each. So I decided to get away from the brontosaurus, because I don't want to give it away, and I'm going to look at raptors. So these are my raptors. I have a starting population, and we see they look very similar, but I have different sizes. So I'm just going to call them small and large to keep it simple. Now, in your assignment, the first agent of change is non-random mating. So I want you to get, for your full marks, I want you to explain what is non-random mating. And I'm doing point form to keep it simple. The process in which a mate selects for certain traits. That's competition. Those mud skippers that I showed you in that video or post that video, they jump high. that's how they're going to get mates because they're the most fit, they're the sexiest, whatever. They're going to reproduce more often. They're going to be chosen more often. So I said, that's what it means. This is what it looks like in my raptor population. Size is key, I said. So I'm making this up a little bit. We don't know what your brontosauruses are going to do. You can have a little fun. I said larger raptors are more sexy. They're selected more often. So they're going to outcompete and be more fit and fight the other one, basically. So the final point I want you to write is what that means for the population. That means we're going to see more larger raptors being born. I then have a picture of the second population here. So what changed? Well, we see there are more larger raptors. Your second agent of change in yours that you're going to be doing is mutation. So full marks again. What is a mutation? So any change to the genetic code. What is that mutation going to do to the population? So I said it's going to give some raptors feathers, which is a new variant on the species. And what is that going to basically, so what it looks like and what is it going to do for the population? So I said it's going to keep in more heat. So just keep it simple. So let's look at how my population changed. So we see I have some populations with feathers and some without. Now, the next agent of change for my raptors was natural selection. What is it? Blah, 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 blah. What is it in my population? So relate it to my exact population of raptors. I said feathers provide insulation for endothermic raptors. So they're more resilient to cold weather. Now, there's a lot of new studies that are saying dinosaurs were endothermic. They were warm-blooded. So yeah, they would be insulation. So what that's going to do for my population, I said as winters get colder, more feathered dinosaurs survive and reproduce. They're less likely to die in a cold snap, anything like that. And then my outcome would be I have all feathered dinosaurs. So you see, I had a little bit of fun with it, but I'm being very clear of what is the agent, what does it look like in my population, and how does it affect it. If you can do that, you are golden. You have to do it 5 times. So you're going to also have to do genetic drift and gene flow, I believe. I'm not going to give those away. Check the notes, number 11. Remember what genetic drift is. That's going to be some kind of random event, such as like a bottleneck event, or maybe the founder effect that is going to select a small portion of your population. So it's not going to be selection, it's going to be kind of random. So have some fun. And gene flow is what happens when we have things from 2 populations intermixing. So when we have some coming from a different raptor population over to ours. So those are the most challenging. Now, some of you are probably wondering, do I have to do these pictures? This is not the best formatted assignment. So if you start putting pictures in, it goes wacky. So that's why I did it on my own. I want to at least see your final population. So I want to be able to compare what the starting was to the final population after all those agents. You can draw it with your hand, take a photo and just put it under here. You can do the whole thing like I did in another document and submit it with this document if you find this easier. I just did this in Paint. But to get your full marks, you should be very clear, and I should see how that is reflected in your final population. If you do not have a picture for number 5, I will take away a mark. So that's your warning. If you do them all, that'd be even better. But I'm only relying, I only am going to take a mark away if you don't have this one. Cool. Now the last part is all about speciation. And remember how I always yell and blah, blah, blah about biology is always changing. It's not deterministic, which means we never know the exact outcome. People debate everything. That's where this assignment kind of comes from. The idea is you have 8 sets of species cards. On these cards, there's 2 different species. There's one paragraph discussing those species. Your job is to put them in order first of all. So we have this kind of line here, and there is no 100% right answer, like which cards show a definite same species and like what exactly number 2, 3, 4, 5 is. There's a lot of flexibility here, so I don't want you to stress out and blow up because you think it has to be in this correct order. There's no 100% correct order. There are some very wrong answers that will lose you marks in this line. So, for example, I'm going to scroll to the bottom and see what these species cards are. If you look at something like a salmon and a goldfish, those are very different species, and you know that. They have different environments, freshwater versus salt and freshwater. So they grow up in the ocean, they don't interbreed, they don't come in contact. So what you know about speciation is enough to say, yeah, I know these aren't species. So I've given you this one as the example. I've highlighted N for no, they don't interbreed, and Y for yes, it's a different habitat. You may just do something simpler like delete the letters and just leave what it is. And then you write the 2 species here. So when I said there could be some very wrong answers, pretty much that means when things are definitely different species, like this one, it's a dead giveaway, and you say, oh no, they're the same species, salmon and goldfish definitely interbreed, that's where I mean the definite wrong answers can come. You're going to see that most of them are this blurry gray area in the middle, and so somebody's 3 could be, I'll use Christie's 5, and you both might get full marks. So it's a little bit challenging. It gets you to think, and you have to be just like a scientist of drawing that species line. As I said, for each one, reading the cards, you have to say, do those 2 species interbreed and a different habitat? So that's how you fill out this part worth 7. And I believe most people should do very, very well on this part. And there's 2 questions to follow up what you did here with your continuum. It says, where would you draw the line? That means you're going to have all these cards in order. And I'm going to force you to draw an exact line between them of where on the left we have the same species, and on the right they are not the same. It's a lot of gray area. That's what makes this so challenging. So to get a full mark, you might say 1 through 7 are definitely different species. 8 is definitely the same species, and 8 is definitely different. So that's where you decided to draw the line, and then you just explain why did you draw it there. So why are 1 through 7, all those cards, the same species on those cards, but 8 not? So use some of the information we talked about, especially in our meeting on that PowerPoint, like the interbreeding, the viable offspring, the habitat, things like that, okay? So 3 marks, so I'm expecting you to not just say, they don't interbreed. That might be 1. But this one is by far the most challenging. You have your 8 cards, but it's also really interesting because I always say the firm definition is, do they interbreed, yes or no? But you'll see there's a lot of blurriness and gray area to speciation. And that's what makes this assignment so fun or painful, depending. But that's it. Feel free to ask me any questions. This will be due July 9th at 11:30 p.m. Good luck. Ask if you need any help. Take care.